right, welcome everyone. Going to give folks a few minutes to join today. And I'll give a kind of quick intro about Acelab. We're helping out hosting today's event presented by Linda Potter from Hohmann Barnard. Today's an AIA CEU approved virtual event. I'm very excited to get started with this one on specifying air barriers. Linda and I were just talking about how this feels like a really relevant kind of current topic in terms of like addressing the building envelope. So I think this will be a great presentation today. And let's see, it looks like we've got some folks joining already. So I'll go ahead and get started. As I mentioned, my name is Bo. I'm with Acelab. Acelab is, let's see, started by a team of architects. So I'm a former architectural designer myself. Here's a quick snapshot of some other folks on our team. And Acelab was really started with the goal of creating tools for workflow issues that we were experiencing ourselves in practice. So our founders, Fredon and Dries, started the company a few years ago with the goal to create a single tab platform where you can research and specify building products all in one place. So this is kind of a little illustrative example of some of the issues that our team is working to solve. So being able to find the information that you need, get in touch with reps at the right time, track down old product information, and really have all of the information that you need in one place when it comes to your product research and specifications. I'm going to quickly jump over to our live site to show you how to find Hohmann Barnard on Acelab's platform, and then after that, I'll take us over to today's presentation. But if anybody would like some more information on Acelab, how to use our platform, feel free to reach out to me, shoot me an email after today's webinar. I'm happy to do another quick demo and walk you through. So I've signed in. This is my custom dashboard. I can pick up on searches, save products, converse with reps directly on the site. I can also upload projects to kind of keep all of my work and research organized. If you know exactly who you're looking for, you can always use the search bar in the top. Just type in the name of any manufacturer. It'll start to auto-populate, and you can jump over to their page on Acelab. You can reach out to Hohmann Barnard's team directly through Acelab, and you can also explore their products. You can save them to your projects. So once you hover over a product, you'll see the shortlist tab. Super easy to save products. And what's great about that is it saves it to a really handy comparison table, which I'll quickly show you. I've already saved a few of Hohmann Barnard's products to one of my projects. So I'm just hopping over here to my project portal. Mine's a bit messy since I've got a ton of projects in here. Jumping into my general research project. And here are Hohmann Barnard's vapor and air barrier products that I've already saved. Once I save them, they're already in this handy comparison table, so you can scroll down, see an overview of product information. This is also collaborative, so you can add comments and add documents back and forth to this page to kind of add in additional levels of detail. So if you reach out and you receive, some more specific technical information, you can always link that right onto your shortlist. You can overview of product highlights, you can see design options as well as performance data all mapped out. So it's a really great way to be able to kind of assess and compare the products that you're looking to use and to save and store your information for future use. Got certifications and then downloads at the bottom. So you don't even have to chase down downloads and save them into your Google Drive folder. It's really just one click to shortlist a product, and then you've got all the information that you need saved in one place. So that can be a great way to get in touch with Hohmann Barnard's team and to start evaluating their products for your projects. And if anybody's interested in learning a bit more about how to use Acelab, then feel free to reach out to me. My name and email is just bo@acelabusa.com. With that, I've got a few housekeeping items. So the first is that today is an AIA presentation. So I'm going to send over a quick form in the chat just to make sure we have all your AIA numbers. Please fill out this form when you get a chance at some point during the webinar, and we will be sure to report your credits directly to the AIA. And I will try to send this form again at the end, so in case anybody misses it, we will have that option again at the end. All right. The other thing I want to mention is please feel free to submit any questions to the Q&A during today's webinar. We'll definitely leave some time at the end to get to those. If anything seems urgent, we'll try to answer it during the presentation. But if we don't get to your question, we will also have a record of that so we can follow up with you after today's event as well. All right, I believe that covers all of my housekeeping items for now. I want to thank everyone again today for joining. We're really excited to have you all here. And with that, Linda, I'll pass it over to you for today's presentation on specifying air barriers.
Okay, let's see if I can get this thing shared and we'll get started.
That looks great to me.
Okay, so as Bo mentioned, my name is Linda Potter. I work for Hohmann Barnard. I've been here almost 4 years, which just seems crazy to even talk about. But I live right in the middle of Nebraska, even though our company is headquartered in New York. We have manufacturing facilities all across the US. We are sold through every major city. So if you are wherever you are located, you have access to our products. We sell through a wide distribution network. But also in the last 4 years since I've been there, we've had an architectural team dedicated to you and what you're trying to do to put these projects together with the right materials to meet ever-changing energy codes. And that's where we land today, is that most people know Hohmann Barnard as joint reinforcement, masonry anchors, flashing, all things masonry walls. You don't necessarily think about us as air barriers. And we have been in the air barrier business for around 15 years, and we are continuing to kind of put our resources to where we're going as an industry, which is high performance buildings, which is understanding how critical the building envelope plays in whether or not you're able to achieve these energy efficient buildings or not, and how that goes into the system of your backing, your substrate out to whatever you choose to clad that building with. And so as a company that's transitioning to rain screen, we're having more and more conversations of the barriers that exist behind these thinner claddings, instead of maybe always thinking about us in mass walls and mass wall assemblies. Here's where we're heading and where we're spending a lot of our dollars in terms of innovation and ensuring you have the materials in front of you that you'll need to design buildings accordingly. So don't let this seminar fool you. I know it says specifying air barriers and what you need to know. Hopefully that doesn't sound super boring. We're going to try to keep it really relevant in terms of how you can maybe take something away from here to help you as you're putting together your projects to feel protected, that you'll get a good air barrier installation, because we all know that that is the single most important thing. Is you can design this system in a fail-safe way and have everything on paper make sense. But if your contractor can't get it installed correctly and you have holes and openings and gaps, all it's doing is letting that energy leak out of the building, and we're not impacting those heating and cooling costs like we intend to do as we've beefed up these building envelopes. All right, so that's where we stand from today. So we're going to go through. This is HSW credit. I know we need those most when it comes to AIA units, so get those in there and we'll get an input for you. Our description on this was over the last 4 years, as we've been moving through air barrier chemistries and how we look at them and how they impact the energy code, what we've learned is water vapor is that invisible source of a lot of problems in our buildings today. It's important we pay attention to all those building materials. We're looking at them as assemblies. We're looking at them as systems. Instead of all of these parts and pieces that make that up, how often can we get down to the root of saying, how is all of this from the inside all the way to the outside impacting in terms of how vapor can flow through here? Because that is what is going to help you keep an energy efficient buildings, understanding how you're controlling that. So that's what we're going to go through a little bit more today. Our objectives will be understanding how that vapor flow impacts your wall assembly, pros and cons of whether you use a permeable or impermeable barrier, why we have to look at things as systems, and then when you might want to look at a high performance barrier as opposed to maybe the standard basic chemistries we've had for decades now. First thing I'm going to do is go through a little bit of definitions, because I think it's important we all get on the same page, depending on where you're at, depending on the region you live and the contractors in your area. you might refer to different things differently. So we're going to talk about the difference between weather barriers, water resistive barriers, air barriers, and vapor retarders, or these vapor barriers. And the first thing as we go through here, in my way, I'm going to define this is a weather barrier is the barrier that protects your building from all of the weather. It's separating inside from outside, temperatures and environments. It's the complete building enclosure, and it includes all these other layers together. So maybe a water resistive barrier, an air barrier, a vapor barrier, thermal insulation. Those are all those layers inside of a weather barrier you're considering of whether you need it or don't need it, where it goes in the wall, if it goes in there at all, and ensuring you're not getting these double things happening that are going to cause you to have your dew point in your wall assembly and potentially any of that mold stuff that we're trying to avoid. Your water resistive barrier is that how we're keeping the water from coming into that building, how we're going to keep that building dry. It's the use of flashing. It's how we're going to put all of this together to understand how we're going to keep the water out of here. And it may or may not meet energy code if you just think about water resistive barriers. And a lot of times folks will think an air barrier and water resistive barrier are the same thing because we were trying to keep water out of the building. But really, you and I, we all know it all comes down to the air barrier, which is what we do to stop air leakage. If we stop air, we stop water. It doesn't always true if we stop water, we don't always stop air. And so we can't kind of use those things interchangeably. We're going to refer to everything kind of as air barriers today and how we're trying to stop the air leakage. These vapor retarders are also commonly talked about, where it's this intention of reducing that vapor transmission or the rate at which the moisture moves through a material. And we're asking ourselves, do we want to stop that? Are we allowing it to go through? How are we managing that? We're thinking about the whole building. We're thinking about how do we not trap moisture where we don't want it to be? And humidity plays a big part into all of that. So that's our definition of today. And the reality is that we get caught up a lot talking about vapor diffusion, when I'm sure you've seen this visual, which shows really what we're dealing with impact and moisture when it comes to vapor diffusion, where if we allow that water to go through, it's really minimal in this cup, but still important if we're thinking about high performance and we're thinking about really impacting the energy consumption of our buildings. However, the biggest issue is that if we have gaps, openings, holes, and allowing air to come through instead of just the rate of vapor moving through these barriers, is where we see this big, massive water penetration, major water leakage, big issues with liability, and all the things that come with when air barriers aren't done well. And so really, you've got to have something that's continuous. That's the single most thing. And all of you know that because we've talked about this forever. You've sat through probably hundreds at this point of seminars on air barriers over the last, 20 years. And so continuity matters. And how do we help you figure out how to make sure that you're able to express that in your specifications or project documents so that contractor understands what you're fully after. But before we get there with that, let's spend a little time on vapor flow. Here's what research has taught us over the last few years. Higher moisture levels equal higher heat loss. And so when we think about long-term exposure to those high moisture conditions, we're talking about potential damage to building components if we allow them to stay wet in any way, whether it's from trying to stop vapor and it just sits there wet as we wait for it to ventilate and dry out, versus if we allow for that vapor flow to allow for that drying to happen faster, more organically, and design our buildings in such ways. There is a really great case study that I stumbled on a few years ago that really helped spell this all of this out, where we talk about some of these visuals here. And I'll share this case study with any of you after this, should it be helpful for you as well, or you want to dissect it a little bit more, talk about it as your teams, as you try to decide what you're going to do if your spec needs some altering to make sure you've got what you need in there for your buildings the way you're designing. We're going to go through part of this a little bit later. I'll talk through that case study a bit more. But when it comes to specifying air barriers, we're going to spend most of our time today talking about part 1 and part 3, which I think are most critical to ensuring that you get the results that you expect. So in your part 1s, make sure that you have this like section 1.1 and A that talks about your entire system. You're talking about coordination between trades, proper scheduling, sequencing of work, pre-construction meetings, inspections, tests, reports, independent. You're talking about everything that's included in here, procedural, admin-wise, of what it's going to take to actually pull off an airtight building enclosure. You're also going to want to spell out the responsibilities of your contractor. This should be understood. We believe, and I like to believe, I am a huge advocate for trades and construction, but we also have a wide range of contractors that are working on your projects. Some that are beyond qualified, and some that you want to just make sure that you've done your due diligence to make sure they understand and you've spelled it out in your documents what you expect from them. So, which is that they provide the coordination of the trades. They are in charge of the sequence of construction that make sure that the air barrier is continuous, which means they are responsible for ensuring transitions between materials and assemblies and materials and substructures and walls to roof. It's quality assurance procedures. They are telling you what they're going to do to make sure that they are going to do the quality control. And let's see, testing. They understand what you expect, that they verify that all of this is going to be part of what they're going to give you back. And they're going to show you the sequence of install and how they're going to handle all of this. You're going to make sure that they know that they're going to build a mock-up and that what you want from that mock-up should be something that's going to show those transition of materials and assemblies. So everyone, before the work starts, understands exactly what that means. That should be spelled out so that you are safe. And it doesn't come back to you that everything that they want as the job stop, as they say, what do you want me to do here? I don't know, like you should have thought about this as well. Why are we just now talking about it when the job is stopped now and all of a sudden it's urgent that I figure it out? Here's some of the things that we can do to get ahead of it, okay? Inside of that, then you're going to want to spell out what you expect from a substrate. Communicate your expectations. When we have good substrates that are ready as air barrier substrates, you minimize the detailing, which is less time and less money. Now, here's why this matters. Most of the time, this is not all of the time, but in my experience, most of the time, the folks that are installing your substrate are not the folks that are installing the air barrier. This commonly happens here we'll just use my background, which is masonry. If the mason is laying up a structural wall, and for years and years, they've laid up structural walls, and what they're doing is they're either leaving the mortar, however it is, because it was always thought to be structural, you're covering it up, it doesn't matter. So those mortar joints are not clean, they're not flush, they're not cut off, it's messy, or they're cutting it flush. And if you've ever seen a mortar joint, I should note to self, I'm going to put photos of what we don't want so you can see what I'm talking about. If they cut it flush, you still see all of these open pores. You still see a little bit where air is going to have a tendency to want to flow through those joints. Alternatively, they're going to want to, if they understand it too, they're going to want to tool those joints like you would see in a final brick project. Tooling those joints also causes a problem in terms of air barrier, because if you're using any tape details, you're going to see those tapes aren't going to have full adhesion at every single one of those mortar joints. And so we have to tell them, like, when you build your structural wall, we actually want you to float those mortar joints like what a tile setter would do. So that you see what you see here, which is fully flat and minimizing as much of those air pockets as possible so that this is ready for air barrier to go right on it. Same thing would go for sheathing or anything else that you might be putting your air barrier on. Ensure that they understand what you mean when it's air barrier install ready. Otherwise, there's just too much misunderstanding or miscommunication about what that means. Pre-installation meetings, like I know they're in most specs, but let's make sure that we just spell it out what we want those to be. Where do we want them to be? When are we going to have them? Include everybody. We're going to have a mock-up. When do you want the mock-up? Sequence of materials, like how are we going to sequence? So those are things we're going to talk about at the pre-install meeting. Make sure everyone there has a plan. The substrate prep, we're going to talk about that there. Compatibility between all of the materials. Coordination of who goes first and when do they go first? How much time is needed between to cure? All of these things, we're going to work through those special details. Because you can look at all of the manufacturer's details that are out there, and inevitably they don't match single as-built condition, it feels like. Most people can say, like, okay, I can bridge the gap from here to here pretty easily to see how we're going to modify that to fit this as-built. But there's so many projects where you have these very one-off scenarios, and it's going to require a lot of collaboration between the design team and some of the fireproofers, or, you know, what are we trying to achieve and how are we going to detail this? Get those handled before, so that we're not stopping the job and trying to figure them out as we go, or worse yet, that the contractor just ignores a complicated detail and just moves on, covers it up, and you never see that it happened. I know it happens. And then removed by others. We really don't want by others in here, just because who's going to pick that up? We need someone to handle it. Let's make sure we assign who's responsible for that. In terms of compatibility, we're looking at the major things you're going to be mindful of when you're laying out materials or detailing. As you're figuring these things out, you're going to think most about roof to wall connection, foundation to wall, which was interesting because, again, we're looking at the entire building. We're looking at all 6 sides. And some manufacturers have all 6 sides materials to ensure that a single source manufacturer can handle all sides of the building, because you want to make sure everything transitions into one to the next so that you don't have any gaps or stops in products, right? We're going to wrap it like a present. The problem is that even if it's a single manufacturer doing all 6 sides, you're still having different chemistries and materials that function below grade versus above grade versus roofs or below slabs. They're usually not the same chemistries and materials that may or may not be compatible when touching and going up against one another. And so you're going to want to really understand who goes first, what those materials are, that compatibility, looking at different substrates, the sealants. So in your joints versus over flashings, all the different ways and times you're going to use those sealants, are they compatible with that air barrier? Transition membranes, are we using them? Where do they go? And then what do you expect for warranties? Get those in there, make sure it's spelled out and that everyone is on the same page. In terms of compatibility, it's often important that you get that letter from the manufacturer. As the single person that's writing letters in our company, I'm writing a lot of them, and it may seem like it becomes redundant, but we really do slow down and look at all of those materials that are going to come in contact with that barrier to ensure that if you're going to have a problem or not. Sometimes it's that, hey, we need to use these 2, but in a way to use them is how we're going to figure out sequencing. And then that makes it compatible. And then how do we communicate that appropriately? But make sure that those manufacturers have a chance to get their eyes on all those parts and pieces if you aren't already. It really can go a long way to make sure everyone's on the same page. In terms of submittals, when you get to your submittals in part 1, I think it's just important that we understand what we're asking and that we kind of go through this for a minute. So in some packages, some projects we've looked at, we see instructions being asked for, shop drawings, which is interesting because shop drawings, some people think that means manufacturers suggested detailing, or the Air Barrier Association of America's detailing, that we're providing some ideas of how we're going to do this. Some projects actually want specific shop drawings of their project with as-built conditions showing how they're going to manage all of the details on that specific job. What do you want? Spell it out and put it in there, because it's completely different cost for a contractor to do shop drawings as manufacturer's standard details versus paying someone to lay out the entire building, whether they're doing that themselves or they're using a third party or manufacturers doing it to do some of these project specific shop drawings. Just make sure we're clear on what we want there and the cost impact that can happen one way or the other if we're not clear about what we expect there. I think it's important we talk about contractor qualifications. This is where I think you most have control over how well that project may or may not go. So some things, I mean, some folks just throw in the ABAA contractor certified materials as well as installers. I think that that's fine. I think that though the problem is depending on where you are located, you may or may not have an ABAA certified installer in your market. And then what? And we always have concern, especially today, from building owners saying, does that limit my competitive bid? All those kinds of things. So other ways that we've seen around this, I'm sure you've seen it as well, is, okay, maybe we have the standard to be ABAA certified as a contractor, which just has them demonstrate that this is a serious business for them that they've invested in. And as such, typically one would say they are more qualified in installing it simply because they've gone through the effort and paid the money to be certified. However, you could also do X amount of projects of this size and referrals, right? Or so many years in business for X amount of projects that they have installed on. There's a lot of different ways. We've started to see where they've had to submit their quality and assurance program so that you can see how they're going to manage the quality of their air barrier install. And so maybe they don't have an ABAA certification, but you're going to require an equal of some fashion that just demonstrates that they're not practicing and learning on your project and having a nightmare go down in terms of air barriers. So those are just some things on contractor qualifications. Same thing on test reports. What do you expect there? Do you just want the standard test report or like data sheet that says, yes, they meet those tests, or do you want to actually see the tests? Do we need it to be an ABAA certified barrier product so that you feel confident that they are an air barrier manufacturer that's going to give you a quality product that you can count on and rely on? There's a lot of manufacturers out there, not as many that are committed to and part of ABAA. Here's just more on shop drawings. This is typical what you will see from a manufacturer's detailing. And again, it's generic. And how often are we designing buildings that are generic anymore? And so you might need some special detailing to figure out those tricky parts of the building, which are your transitions and your weak points. Let's make sure everyone has spent time there to figure out what we want. Some of the tests that get done, again, there's oftentimes we think a manufacturer is going to do the testing, and while we own the materials, most manufacturers of air barriers own the testing equipment. Most of the time you're going to want to have those be, or all of the time rather, you're going to want to have those be third party administered on the project. That way that you make sure the system is calibrated, you make sure it's a professional, you make sure that there's no skewing of results. There's just something leery about the people who are selling air barriers. You really don't want them testing things. You don't want them be doing the inspections. You don't want, because it's just too blurry of a line when you're selling something and then trying to decide if it's acceptable for an owner and for your projects and what it has there. So we often like those to see those be third party that's doing that, and then ensure that the contractor understands they're responsible for paying for those third party testing and how many of them that you want. When it comes to part two, it's actually pretty simple. We are trying to decide, like, what do we want for the requirements of your air barrier? This is where we're going to go into a little bit more about case studies and when you're going to want one versus the other. Now, I am not a building science expert. I am not, I don't even have a commissioning under my name yet. I'm like preparing for said things, but I'm simply a product rep that I have spent a lot of time absorbing information, but I am not the expert here. So I refer to a lot of other case studies that have been done, or to your building envelope consultants that would know how to guide you in some of these things. What we tell the industry is, you guys have decided what you want. You have designed this. And as such, we need to install what you have designed for, whether that is a penetrating like we're talking about sealant, whether that is vapor permeable or it's a vapor retarder. Whether it's sheet applied or fluid applied or spray foamed or whatever you're going to do for your air barrier layer, that you've thought it through, and we just need to provide what you've put in here. So the things that when it comes to putting your products, like there's things that you're going to want to put in here in terms of just, do you want it? Most of them is, do you want them permeable or not? A lot of those ASTM standards, the materials in terms of how you want those to be, if we just refer back to ABAA, that's got a lot of those standards in there about what we need it to do. Most of the manufacturers on the market today are going to meet all of those tests. They're going to meet the vapor permeance and the water penetration resistance. Like you're going to look for NFP 285 if that's important because you're on multi-stories. There's a lot of things you're going to pay attention to, but you're going to decide what you want there. And when it comes to finding your ASHRAE 90.1s, you can do that by material, assembly, or whole building testing. Most of the time we see assemblies being what we're looking to, because we're looking at not just one material, but how it interacts with everything around it to ensure that we're going to get those results that we're looking for. The struggle, we're seeing a movement towards whole building testing. It may not be a popular opinion. My opinion tends to be at this point, we can test for that whole building test as a way of just setting the standard for what we're going to allow on a project. But what happens if at the end of a project, all said and done, it doesn't meet that test? How are you going to fix that? And there's a lot of things we're working around in terms of all of these things. I have heard horror stories where the contractor had to pay the owner the cost difference of what they should have saved with energy that they didn't over X amount of years because they didn't have that tight building envelope they were promised. And so there's just a lot of things to think about here when we're talking about how we're going to specify and what we expect as the standard for these things being installed. A rabbit hole I went down on, and I hope that this will be enlightening. If not, I hope it doesn't come across as me trying to preach here, but one of the things we've said is like, what's standards versus what's codes? Like, and a lot of folks and installers and such, we refer to like ASHRAE 90.1. It's not code, it's the standard for your energy efficiency. You get that, but sometimes I have to like clarify that for some groups. And like ASHRAE 90.1 is referenced in IECC, and the IBC requires that IECC is followed. And so all of these standards are laid out in that ASHRAE 90.1 that most all of us refer back to in terms of how it's done and why we need to do it. And those codes change based on where you're designing. And this probably even needs to be updated from when I built this seminar to make sure of where we're at, of what is going to be needed for you to meet code compliance inside of your state, or even inside of your jurisdiction inside of that state. Here's where we're going to dive back into that case study a little bit more. Permeable versus impermeable. For a long while, there were certain regions based on your climate and humidities that it was a no-go, only doing vapor retarders. I've got to stop the vapor. We cannot allow vapor flow through. And then there were other parts that you had to allow it. In Nebraska, we were always on the wrong side half of the year. So what do you pick? It was like, just shoot a dart and we'll see where it ends, and we'll just design that way, which is not what I recommend, right? So we think about climate, we think about humidity, we think about temperature, was informing those decisions about what we choose and how these buildings start to come together. But we said earlier that higher heat loss, the more humid that area is, the more moisture we have, the more heat loss we have. And so that says to us, like, how do we then start to think about incorporating permeable barriers that allow that vapor flow into our designs, no matter where we're located? What does that look like? It's beyond what I'm capable of, but this case study did a beautiful job laying that out. It's done by Momentum Performance Materials. I have an entire study that I could email you after if you want to dive into it more, but it's the only time I've seen this beautiful wall section laid out where we look at 7 different wall types. You're looking at here, cavity insulated on a framed wall, permeable exterior insulation, impermeable exterior insulated, permeable exterior insulated on masonry. So we're looking at mass walls, permeable split insulated on framed wall, impermeable split insulated on framed wall, and an impermeable interior insulated on masonry. So there's a lot of different ways we're putting these walls together. And then they're looking at it between the 8 different climate zones. And what they found was this beautiful statement that we hear every day, which is it depends. When do you use one or the other? And it always depends. But this chart that you're looking at here, it's got those different walls laid out on the left and the climate zones on the top. And what's important that we look at today here is saying the green dot is when they suggest low permeance barriers. And you also see this dashed line up here. So inward flow is the bottom, outward flow is the top. So it's saying in climate 1, in the stud wall here, if I want my outward flow, if I want to flow my vapor outward, I'm going to use a low permeance barrier. If I want my flow to go inward, I'm going to use a high performance, no interior vapor restriction. As I move over to climate 7 and 8, I get the high permeance that is allowed. So all this to say, like, you can in every single one of these climate zones and all of these wall assemblies use high permeance barriers depending. So if it's orange, that means no interior vapor barrier restriction is needed. If it's yellow, it means, yeah, you can use a high permeance air barrier, high performance, that allows this vapor flow so that we get drier wall assemblies that are more energy efficient. But you've got to consider everything from the interior wall, everything outward, that all is worked through. And that is where your building consultants are worth their weight in gold, is they're helping you figure that out, because it ensures so much of your mechanical engineers, everybody's figuring out what are we doing here and ensuring that we get what we want. We've thought through all of that. So again, when you talk about, do I want one versus the other, and that comment is it depends, we're talking about what do you need that barrier to do? Because high and low permeance barriers can work in all climates, but everything needs to be considered from the inside all the way to the outside. So we're not just looking at materials, we're looking at that specific wall assembly on this specific project, which means I've seen a lot of architects start to develop standards of wall sections so that they can start to understand all of the components that we need to go in here that supports that wall assembly to ensure we get it built the way we want it to be built. The other considerations that you're talking about is high performance barriers are always vapor permeable. So STPEs, silicones, they're all vapor permeable. And so other things we're thinking about in terms of barriers are saying, do we have open joints on a project? Are we using a rain screen cladding that we're going to have open joints, which means do we have potential for UV that is going to be indefinite on this barrier? We've got to choose a barrier that can handle that can handle the wind loads or any of the other loads that might get put on that barrier if we're allowing some of these different panels to be part of this. We can't just look at them in terms of saying one size fits all and the type of barrier that we're specifying. We're looking at construction timeline more than we ever have. Is there a barrier that allows to go on faster one time, not multiple coats, that is easier to detail, that can get my project enclosed sooner than later? We're looking for those. What about rain readiness? Do you have a rain problem or moisture problems, or where are we at that we need to, those real life job conditions that are going to slow down a project because the weather just isn't cooperating? Is that important that a barrier might hold some of these different traits? Do you have an owner expectation, net zero? A lot of schools today that are really asking themselves, like, how do we build this in such a way that I can have a net zero project? Differential movement. You've got a lot of different materials on buildings now. Rarely are you building a building with one cladding with openings all the way around it. We're transitioning all kinds of things. How are those materials moving, and do you have a barrier that can accommodate that moving over the course of its lifetime? So when it comes to an STPE, the benefits you get from STPE technology is, one, it's vapor permeable. So you're going to have to, you can use it everywhere, but again, you're going to have to look at some of those wall assemblies and try to decide, like, where am I putting it? When am I putting it? What else has to change along the way, from my insulation type to my cladding type to whatever I'm putting on the inside of the wall on the other side of all of this vapor flow. It can be applied to a damp wall. So we see this really common in the Pacific Northwest, or where we constantly have rain and just things just don't dry out. The rain might stop, but then it's like, if we have to wait for that wall to dry out to put anything on it, we might never get a barrier on these things. So that's why STPs are really common there, because we can put it to a damp wall. It's got long-term UV resistance, so it can work behind those thin cladding panels that you may or may not have joints between. It can be applied in low temperatures and high temperatures. It's a single coat. It's got high solid content. That's what you're going to pay attention to in barriers. Is you can even do this down into like your acrylic and elastomerics, your Gen 1 air barriers that you've seen for years. There's different colors for every type of manufacturer. They're pretty much similar in terms of performance. If you need something high solid content, is what's going to allow that not to shrink. So you'll see that must go on at 60 mils thick because it dries at 40 mil thick. So we've got this change of evaporation of the materials inside of there. Oftentimes the water content, right, is evaporating out of there as it cures. When you have high solid content, the less shrinkage happens, which is why you're able to do those single coat applications, which is really fast for a project. Silicones, again, those are also on the market. I don't know if you've seen them yet. I really love the silicones. They just feel cool. It's like something about like feeling an entire building envelope that's like this rubbery feel. You know how silicone feels. It's pretty cool. Vapor permeable, again, long-term UV resistance, that really wide range of temperature applications, big for a lot of us that live in cold weather climates. 0 to 150 degrees, another single coat application, their primerless adhesion. They maintain that elasticity. You understand silicone. You know why you like it for sealants and joints. That same concept can go to your entire building envelope, that as things are shifting, as things are moving, that barrier moves and maintains elasticity with that for the life of that building, or the life of that barrier rather. So something to really think about in terms of if you've got a project that's high profile that is in something you need to be mindful of what silicone can do for you on a project. So when it comes to part 2, what you're going to keep in mind is we don't want to see conflicts. If you have thought through what you want for the chemistry of your air barrier, whether it's going to be vapor permeable or a vapor retarder, whether you want high performing barriers or just a standard barrier that's going to be your everyday barrier that just is maybe it's mass wall in front of it, so it's not as important, it's not seeing the loads, it's not seeing UV, then you can't just put all of the barriers down and say pick one. You're not going to get what you want. So, right, like we see a lot of things where there's VPs and then there's a vapor barrier. Or this one here is showing you silicone and just a standard VP. The pricing won't be the same. The performance won't be the same. And so specify what you want. Most of your manufacturer's reps will help you build your spec out to include those 2, 3, 4 dozen, whatever you want for manufacturers to be listed in a spec. We just want to make sure you're putting equal performance to equal performance, and let the contractor then pick what they're comfortable with. There's nothing wrong with allowing a contractor to have options, because they all have one that they prefer. And you and we're both going to benefit. Our owners are going to benefit from a contractor working with a material that they're used to working with, because they're going to know how to install it the better way possible. The thing that you need to be aware of, though, is that they can't just substitute what they want if it doesn't match what your design intent is. Like we ask our reps inside when we're training them, like, can you substitute vapor permeable for just a vapor barrier? And the answer is no. Like that's already, that you can't swap one for the other. So we want that same thing to be listed here. We want you to be very clear about what barriers you're going to allow or not allow. It may save you time on any of these substitution requests coming through as well without researching it. Let's get some things in here that make sense. Okay, part 3. This is the execution part. This is the part where it's important that you know what you're looking for, but also there's not much always the control you can have over that. So this is how the installer is doing their work and how they're pulling it off and what you're going to look for. So just a real quick of the things that you just want to, if you're doing a job site visit or you have a chance to look at the mock-up, these are things you're going to want to look for. Look for your fasteners. Are they overdriven? If they are, it's a potential for air leakage, and those things need to be, a bead of sealant needs to go over the top and tooled. some kind of detailing material. And usually we're going to detail first. Now, that's not always the case. You're going to look at the manufacturer's installation instructions to know what mil thickness what product goes on, and whether they detail first or after, or when this all happens. That's going to be specific to the product, but you're going to want to know at some point, you've got to detail that and make sure that contractor knows when and what they're using to do that, and that they understand that we're not just going to spray over that and leave that. When it comes to corners, we want those outside corners taped or some type of liquid, fluid, extra around it, because honestly, those corners are what takes the beating on projects. So it's extra protection, and there's also more potential for movement there. So account for that. Make sure that these things, those are the places that are most susceptible to problems. When it comes to penetrations, we hope that penetrations are cut into a project before the barrier goes on, but we all know projects where air barriers on, like a glove, everything's perfect, and then some electrician came through and cut an opening because they forgot to put an electrical socket in at that point. And then who's making sure that that gets detailed and finished in the appropriate way, that we just don't leave it as is because this trade's already gone. Like, those things need to be thought of. But when it comes to penetrations, we're going to detail them properly. They are always a potential for air leakage. Most of them are round, and so you're going to want to likely use some fluid applied because it's easier to get that installed and fully continuous. Yeah, so penetrations. Transitions, again, you're going to use this pen test, the concept of when, if I take a pen and I go around the building, if anything stops, if I have to pick my pen up, then I need to figure out what I'm doing there. And a lot of times these are your transition areas that we want to pay special close attention to. When it comes to voids, we want to fix them. They are air leakage offenders. We have to stop that. That's where all this stuff is going through. And it's also a by others. Who's responsible for fixing that? We hope it's just not the air barrier guys going and spraying over the top, that someone takes the time to fix that. Critical details you're going to pay attention to. This is your roof to wall, a really common by others. Who is bringing those transitions together? Is it the roofer's responsibility? Is it the wall responsibility contractor? This is where we're doing a lot of detailing, where we decide, is the roofer coming down and then the wall guy going up over, or is the wall person going up and roofing's coming down over? And a lot of that's going to depend on the types of materials that are being used and a compatibility. Make sure there's a plan for it. Someone better know what it is that's specific to the materials on that job. Same thing for foundations wall. Spell out how we want that to look. I've seen some really nasty things out there that end up happening. We want that air barrier to come all the way down before the rest of these components go on top, because it's like a present. So how are we managing that below foundation into that above grade wall assembly? How are we bringing those two together to meet? Who's responsible for that? Walls to windows, we're going to want to see that those openings are handled. And some of this gets tricky when you're looking at mass walls or using brick in front of block or brick in front of anything, is we talk about flashing that's through wall flashing, which is completely different than opening flashings for air barrier systems. And we see a lot of confusion and conflict there when we have those two systems that meet, where we're talking about transitioning into the windows that is part of an air barrier assembly, separate from if we're flashing for any of the claddings on the exterior of that. So all those things need to be coordinated. The rule of thumb, if it was 3 in, 3 out. So 3 inches around a penetration, 3 inches on either side of a control joint, 3 inches inside a window, 3 inches outside of a window. That tends to be like the industry standard norm of what you're going to want to see, so that we've got this whole thing wrapped as a present. Change of substrates are a big issue, where one trade stops, the next starts, and who's bringing them together. And oftentimes they incorporate multi-steps to get something detailed properly. And we want to know what those are before we start a project, because like an instance of this, where we're trying to fill the gap between the CMU and the structural steel, could include, and by the way, there's a lot of different ways this could be done. I would have your contractor tell you how they want to do it, and then you decide if that is appropriate or you agree with it or not. This contractor chose to slush it full of grout, wait for that to cure. Then we're going to come back and we're going to put transition membrane across that, and then they use some sealant to kind of make sure that that transition material was appropriately fixed to it. But it's multi-steps, and you're the one that's going to decide, like have them tell you what they're going to do, and you decide if that is acceptable or not. But this type of thing can slow down something if in the middle of the project we're just now deciding it because we ran upon it, and now we've got to stop for a week because we got to let everything cure. We got to figure out what we're doing, and then we've got to let everything cure so that everything can be built out, and we've just lost time. We just don't have time now, right? More on penetrations. Some are square, some are round. Make sure they have a plan for how they're going to fill those in. Movement joints again. If we have movement joints for a reason, because we expect our buildings to move. So as such, you've got to detail your air barrier in a way that's going to allow that building to still be able to move without peeling things apart or causing problems where you would now have a crack or an opening in your air barrier because your building moved. We need to know how we're handling that. Shelf angles are a really hot topic right now. Only relevant if you're using a full veneer masonry on the outside of your project. But if you are, the standard way of handling this was your angle would go in place, and then you would try to air barrier around this thing. Lots of tapes, never fully continuous, because there's no way you're going to get fully continuous air barrier back behind that once it's already installed, which is why you've seen a big push towards when shelf angles are a part of a project that you would move to an offset shelf angle system, which allows you to have something to air barrier on entirely before you attach the shelf angles, and then you're just detailing around those areas. Makes it faster, and it is extremely important to the overall impact that has on your air barrier, if you can get that fully continuous or not. Anchors, again, like who thought anchors of how you're keeping masonry on a wall would be part of an air barrier discussion? But it is, and you know that because you have to think about that. Building envelope is the single most critical part of a building, in my opinion. And so anything that penetrates through or has any interface with, we've got to understand, is it causing a potential for air leakage? And so we're seeing a movement even away from these hook and eye assemblies into these post-installed sealed anchors to stop that air leakage if we're going to have to penetrate them. Make sure we have a plan for everything that comes through that, right? There's a lot of different insulations that are used out there. I don't necessarily have a preference. Just know that the insulation that you use and the air barriers that you choose to use and the anchors you're using with it and the flashing that gets used with it, if all of those things are present in a wall assembly, we think about compatibility again. We think about if we have a vapor permeable air barrier, but we have an impermeable flashing, or I'm sorry, insulation, what are we doing for that vapor flow? All those things need considered inside of that entire wall assembly. When it comes to flashing, the thing that's most common is that if you're still using asphaltic-based flashings in your projects, they're typically not going to be compatible with most air barriers. And so just keep that in mind. It may be time for you to update some of your flashings because of your air barrier building envelope strategy. Making sure that during QC, during thickness, we understand we have these mil gauge, we're understanding thickness, we're understanding adhesion. We have this visual approach to see, are things thick enough or are they not? If you can see the words dense glass through a barrier, probably need more barrier on it. If you can see the pores of a block, probably need more. But the reality is those mil gauge, if you're on site, ask the contractor to see if they have one. They should have them. They should be using them all the time. That's the only way that they're achieving and making sure that they're getting that right thickness on there if you're using a fluid applied barrier. Okay, we made it to the end. Understanding that water vapor matters, know what you're doing to put your walls together, clearly define it so that you can make sure that you get the best project possible at the end. There you go.
Thank you so much, Linda. That was really great and informative. Looks like we've got a few questions in the chat. I also just wanted to let everyone know I'm going to launch a quick poll, so feel free to fill that out if you would like to receive follow-up information. It's the easiest way to make sure you get the info that you need. And with that, I will go ahead and launch into some of our questions. So first, we had two people ask if slides will be available. Linda, is that something you can provide?
Of course, yes.
Okay, great. All right. And then let's see. Someone else asked if you could share the Momentive Performance materials resources. So we have a note that you've asked that. We can follow up with that as well. All right. Let's see, Ben. Something that is not often discussed is the application of an air barrier over a vapor barrier material. For example, OSB and plywood beyond 3/8 inch thick are vapor barrier materials, not only vapor retardant. Gypsum and MGO are likely the only products that will allow the air barrier to remain an air barrier. It seems like just a comment, but great comment.
It is, and honestly, there's a lot of that conflict that comes out when these and it's like you're defeating the point at times because of what you have it going over the top of, or the insulation that comes after, and all things that need to be looked at from a design strategy that is it's imperative. So if we don't know, it's like get a consultant in there to help us figure out what you want to do there, and that looks at all of those pieces together.
Mm-hmm. Quick note about the poll: if you're requesting samples, there will also be a quick survey at the end of today's event, so you can add in a request for your sample there. You can add in your address, just to note that. Not sure if air barrier samples are something that many folks will need, but we can see about that after the event if you do need them. All right, another comment from Ben that I typically shy away from specifying contractor certifications in my documents because continuing education for contractors is almost non-existent in the USA. Are there programs offered outside of ABAA that can take up the slack so we can rest assured that we have knowledgeable contractors on our jobs rather than the I've done it this way for 30 years person?
That's a good point. So the thing that I've seen more recently is that you ask that contractor to be certified by that air barrier manufacturer. So directly after this, I'm moving into a virtual, which isn't my favorite, but I'm doing a virtual contractor certification, and it's for the actual installers, where the installers on that specific project, the architect has called out for that those installers need to be certified to use that specific manufacturer's barrier. And I really think that helps. While it doesn't mean anything because it's just a piece of paper, the hope is if the actual installer is there hearing how the detailing materials should be used, in which way, that we've clarified all these things, and they've had to slow down and take a quiz at the end to demonstrate that they know what they're doing. Typically we see a better installation. So that might be one way you could look at it. Most manufacturers have a program like that for contractors to go through that they could offer. I'd like to see us get to a point where it's a hands-on installation, because that to me is like the best way to demonstrate someone knows how to use your materials. But that's a way that I've seen it happen, is manufacturers led, which honestly makes the most sense because every barrier goes on a bit different. You want to make sure they know how to use that specific one.
Mm-hmm. Right. I'm seeing a few questions about certificates. So yes, if you're a non-AIA member, we can send a certificate after today's event as well. All right, let's see. Michael says, what about SIP wall panels, air vapor barrier on the outside? Question mark.
I'm still learning about those too.
Cool.
There are so many innovative solutions today for how we're managing these wall assemblies. And honestly, I've got to believe there's research that backs them, that they know how their buildings perform and that it works in those ways. I think the biggest question we have is, because they're new and they're innovative, are the trade partners installing them aware of what needs to happen in order for them to perform the way they need to? And a lot of those systems, they got to be done almost perfectly in order for them to perform the way you need them to perform, which means it's a little finicky to get that correct.
Right. All right. Let's see. Jason asks, wondering if, can you specify how to deal with penetration of brick tie, liquid applied membrane, or by peel stick membrane itself?
Can you specify? I'm trying to say that one more time. I tried to catch it, but I think I missed it.
That's okay. Wondering, can you specify how to deal with penetration of brick tie, liquid applied membrane, or by peel stick membrane itself?
I mean, I think you can just, the way that I've typically seen it done is that it's a very generic statement, which is some type of detail, the penetrations in such a way that are air resistant based on whatever. So I don't know that there's a way to do that unless you and your team are going to decide what those parts and pieces are inside of that wall assembly. So let's say that you do want to specify an anchor that is self-sealing as it goes through that area. You would just make sure that you've got those in your specification and that we don't allow any alternates. And so there are 3 manufacturers that make penetrating, an anchor that will help with that. And that might be the only way you can really control that. The problem is there's just so many trades involved in those assemblies that getting everyone to communicate and know what we're using to specify that, because everyone then wants to make all these substitution requests. So like we've asked at times where we're saying like, well, maybe we have these 3 wall systems that are allowing different parts and pieces in there, but ones that I have verified, or maybe you just do it on one and you say, and you have to verify that your change meets all these other things and make them do the work instead of consistently, they care about one part, but they don't know how that part impacts the rest of the things that you've spent all this time vetting.
Right. Yeah. Okay, cool. Well, it looks like we're at time. I know we've got a few more questions here. So if we didn't get to your question today, we have a record of it and we can follow up with you after. Looks like there was a few requests for some other information that you shared. So thank you again, everyone, for joining today. And thank you, Linda, so much for today's presentation. All right, I've ended our poll. So just, another note to stay tuned for that post-event survey. Should pop right up when you leave this webinar. And other than that, I hope everyone has a great rest of their Tuesday.
Thanks, Bo.
All right. Thanks, Linda.